the last, and we'll continue. We'll continue with the next things also. So revision. So let us revise first. So set theory. A set is a collection of distinct objects bearing identical properties. So this is notation, you know, elements, different elements are written inside, and it is suppose that an element cannot be written again and again, and there is no any importance to the order also. So ABC and BAC and so many. So if there are 3 elements in a set ABC, then we can write the same in 3 factorial, that is 6 different ways. Absolutely everything is going to have the same meaning. A set that contains no element is called as an empty set. It is denoted by brackets without any element or a phi. So the set, so that set contains 2 elements. This set contains 4 elements, like that. So this is the latest. I have not shared yet. Okay. I was under the supposition that just yes. So see, S1, S2, and S3. These are the 3 different sets. Then we can say that RAM belongs to S1, but RAM does not belongs to S2. RAM does not belongs to S3. So third set is nothing but S3. Then S1 belongs to S2. Yes, S1 belongs to S2. S1 completely is inside S2. S1 does not belongs to S3. Like that. Then we say that A is subset of B if every element of A is also an element of B, and we use this notation: A is subset of B. And so in that case, so A may be a proper subset or improper subset of B. So we'll understand the difference immediately, like this here. We know that any set is subset of itself, and it is our assumption that empty set is subset of any set. And one more assumption is that any set is subset of the universal set. Further, empty set is not an element of a set always. So the set, so these are the things. So A and B sets have been defined, and we realize that can be defined those same element. And here, alternatively, we can say that A and B are equal sets if A is subset of B and B is also subset of A. Then the next definition is proper. We say that A is a proper subset of set B if A is a subset of B and A is not equal to B. That means there is at least one element in B which is not in A. So definitely when we say that A is a proper subset of B, converse is never true. B can never be a proper subset of A. On the contrary, if we just say A is subset of B, it is quite possible that B is also subset of A, and in that case both sets will be equal. And this is the notation for proper subset. We know the union of 2 sets. This is also called as inclusive OR. So A and B is another set which contains the elements which are in A or in B or in both. So in this sense, it is inclusive OR. Okay, so these are some examples. So any set united with empty set is that original set itself. So this is the thing. Now we know that the minus sign is used in relation to two real numbers, and yes, it is used in relation to different sets also, and the meaning is slightly different. A minus B is another set which contains those elements in A which are not in B. So it is also treated as complement of B, assuming that A is the universal set. So relative complement of B relative to A. So here you can see minus, some examples of minus, and A minus B is also called as complement of B with respect to A. We know A minus B equal to A intersection B complement. Then the next operation is the symmetric difference, or the ring sum of two sets A and B is A ring sum B is the set containing exactly all the elements in A or B but not in both, and hence, so this is the definition. If we briefly have a Venn diagram here, this is set A, this is set B. Definitely we must write universal set before that. Then this is nothing but A ring sum B, and that is nothing but A minus B minus, also A minus B united with B minus A, or that is also A union B minus A intersection B, and this is called as exclusive OR. This is exclusive OR, exclusive OR. Okay. So see, ring sum of these two sets is another set which contains elements B and C, because A is in both, so we have to drop that. Then this set will be any set ring sum with empty set will be that original set. Any set ring sum with itself will be an empty set. So these are very much obvious things. Then we are going to concentrate on power set of a set. So here the power set of a set A is PA, is a set which contains all the subsets of it. So we are going to understand these things in better and better way. So here I have already given you. So this is the set which contains empty set and a set which contains A. So these are the two elements in the power set. So here A set consists of two elements. Its power set will contain 2 to the power 2, that is 4. Empty set is subset of any set. Then this will be another subset of the given set. This will be another, and the set itself is subset will be itself. So these are the 4 elements. Yes. So Rampurkar sir is saying that he is giving an opportunity to continue until 10:30. So that is nice. Yes. 46. Okay. Now it is interesting. This is empty set. Empty set. So what will be the power set of this? So we know that empty set is subset of empty set itself. So that will be an element of the power set of empty set, and this is the only one element. So in general, see here cardinality of A was equal to 1 and cardinality of power set of A is equal to 2. Cardinality of A is equal to 2 and cardinality of power set of A is equal to 4. Here cardinality of A is equal to 0, then cardinality of power set of A is equal to 1. So this happens, and you know that the power set of a set which contains n elements will be containing 2 to the power n different elements. I had given the proof by 2 different ways during the last session. The first proof was coming with the first principle of mathematical induction, and the second way to prove the same thing was very easy So that is oral proof also. Suppose there are n elements in a set, then there will be NC0 subsets which contain 0 elements. There will be NC1 subsets which will be containing exactly one element, and so on. There will be NCN different subsets which will be containing all the n elements, and addition of all these, that is NC0 plus NC1 plus NC2 and so on, will contain so this will be, we know these are the terms in the binomial x 1 plus 1 to the power n, that is equal to simple result, and then s. So we have done this, and now this is from your question paper. Let us solve this. So construct the following set. So let us write solution. So it is my practice to write the given things once again. There is one set A, capital A, with two elements. One element is B, and another element is this empty set. Okay. Now let us write the first part, that is A set minus empty set. Okay. So this is nothing but B comma this. These are the two elements minus this empty set. So this is equal to, we have to write those elements in set A which are not in set B. So set B contains no element at all. So obviously the answer will be A itself. So this is nothing but this is equal to A. Okay. Then second part is a set which contains element empty set minus set A. So this is equal to empty set minus a set which contains A, that is okay. So we'll using the same notation so that it will not be any confusion. So here this is a set which contains an empty set minus set A. Set A is containing two elements B and empty set. So this is equal to, what do you think? So a set with empty set is in both, so that is to be dropped out, and that will be a singleton with element B. So this will be the answer. And the third, A union power set of A. Now remember, it is very much logical, friends. See, some things it is not necessary to do everything manually. We can come out with some concrete answer on some occasions with our logic itself. When we say that power set of A is the set which contains all possible subsets of A, so A union power set of A will be power set of A. Yes, but we will be writing it first. So when solving the third part, power set of set A, see, A contains two elements, so power set of A will contain four elements. Obviously the first will be the empty set, then the second will be a set which contains only the first element, then next element in power set of set A, that is subset of set A, will be a set which contains only the second element, this one, and the last will be the set A itself. we know A is subset of itself, so this is B, this one. So this can also be written as, this is phi as per set singleton B, then this is a set which contains phi, and then this B, and this is nothing but A. So I can say this is as A. This is A. So this is equal to A. Okay. And now, no hesitation. A union power set of A will be equal to power set of A. You can understand. A contains these two elements B element and a set, an empty set. So both are in power set of A, so that will be equal to power set of A. This happens always. So it is very much obvious. A united with power set of A will be power set of A. A intersected with power set of A will be equal to A. And this is our final answer has to be, these are the four elements like that. Okay. So nice. Now we'll be moving to the next concept, finite, infinite, countable, uncountable sets. So this is going to be as good as our strong discussion. We are for at least 30 minutes further together. So whatever the time we had lost, that is going to be compensated. And if you are in front of me, then there is no beyond doubt. We can discuss for 2 hours, 3 hours continuously in regard to some mathematical or even non-mathematical topic. Now, what is finite, infinite, countable, and uncountable sets? So we'll just this is set theory, and this is very much analogous with the probability theory also. You may be learning probability theory in detail during your M3. In detail means you are going to study only fraction, very little about the entire probability theory. Actually, probability theory, like another any topic of mathematics, is very vast. But we'll be wondering within first few steps, within first 2-3 steps of each of the topics, and there are so many thousands of steps for each topics. Now we say that a set is finite if it contains finite number of elements. So obviously a set is said to be finite or infinite depending on its cardinality. So if a set is such that cardinality of that set, a set A is such that cardinality of set is finite, we say that A is finite set. Simple. Similarly, otherwise I can wind up quickly. Otherwise, an infinite set. Okay. Now, if I want to list different days of a week, as said, days of a week, then see friends, Sunday, Monday, Tuesday, Saturday, and so on Saturday. So cardinality of A is 7, so which is a finite number. So we say that set A is a finite number. Now B, I define it as number of attempts number of attempts to pass discrete mathematics paper. Okay, so we are going to take care of every possibility. This is your first attempt. You will be passing in first attempt mostly all. Then one possible value of this is 1. Only one attempt. If there is some person who fails, goes for another attempt and it second attempt passes, then this is going to be happen. Then 3, 4, we cannot stop somewhere, and theoretically we have to put like this also. This is the only way. Then if I define number of stars in the sky, number of stars in the sky at a particular time. So C is equal to, see, if I see now, I am able to see sun, but suppose it is hidden beyond the clouds, then number of stars will be 0. If it is coming outside the clouds, then it will be 1, because sun is also a star. In the evening, you may see one more, like that, and so on. So at night, you may see 100, more than 100, there is no upper limit as such. So here we see that set B and C are infinite. These are infinite sets. Set A is finite, whereas set B and set C are infinite sets, depending on their cardinalities. Okay. Now, what is countable set and what is uncountable set? So that is the next part. We'll be writing countable set. So simple definition, a set is said to be countable if we can assign a one-to-one correspondence, one-to-one correspondence with the elements in the given set with the elements in the set of natural numbers. This is simple definition. Now, if this is possible, then we say that a given set is a countable set. If this is not possible, then the set is uncountable set, obviously. Now, if we see set C is here. The first element is 0. Let us have a set of natural numbers. Naisaर्गिक संख्या 1, 2, 3, 4 like that. So these are the natural numbers. So the first element in C, 0 corresponds to first natural number 1. Second element in set C, that is 1, corresponds to second natural number 2. The third element in C, that is 2, corresponds to the third natural number 3, and so on. Yes, there is correspondence. Yes, one-to-one correspondence is there. So if I ask you that there is element number 1000 in C, And what is the corresponding element in the set of natural numbers? So that is 1001. Yes, there is one-to-one correspondence, and that is always going to be there. And in this sense, C is going to be a countable set. C is countable. So we see that C was already infinite set, but now it is countable. So it is C is thus infinite but countable. Thus, C is a countably infinite set. Countably infinite set. Okay, very much logical. Then, which sets will be called as uncountable sets? If there is no but one correspondence in a given set with the natural numbers, then the set will be called as uncountable sets. Let define D. D is the set of weight of students in our college. So we but I have been writing here. So what is the problem? Let me share the screen once again. Some problem was there. Yes. So here I had already given you the definition of a countable set, and the countable set is that if the elements in a set can be assigned a one-to-one correspondence with the elements in the set of natural numbers, that is countable. And if this is not possible, then we say that it is uncountable. Some set here which was comma 2 comma dot 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 is infinite but simultaneously countable. So we say that it is countably infinite set. On the contrary, suppose if I define say D as the weight of students in our college. Suppose the lightest student has weight E and the maximum weight corresponds to 100 kg. So this is going to be the set. Yes, I cannot write this set as 40, 41, 42 until 100. No, absolutely not. The reason, you know, everybody, that when you are standing on a weighing machine and the digits you are see, it is not the case that you will be getting exactly integer values. So it is giving us values until 2 decimal places. And we know that if we try to relate the elements in this set, actually this is less than equal to, so it is closed interval 40 to 100. Okay, closed interval. Otherwise, the only parenthesis is there, that is called as open interval. Means the first element is not part of that set. Here, closed interval 40 to 100. So it is sure that 40 is also member of this set D. 100 is the biggest and the last member of this set, but in between, how many elements? In the previous case, we would have written 0 up to, see, This would have been 0, then 1, like that. So, but in this case, that is not going to happen. Here, suppose this is 40 and this is 100. This is 41 and this is 100. So all real numbers from 40 to 100 are there. 40 to 100, all real numbers from 40 to 100. Is there one-to-one correspondence between the elements in set D and the elements in the set of natural numbers? Let us try to look. The first rational number 1 corresponds to 40. But what is the next element in set D that will correspond to second natural number 2? Nobody can tell. Is it 40.1? Absolutely not. I can tell you that between 40 and 40.1, there is one number, 40.100 times 0 and then 1. But any one of you will be able to tell me thousands of real numbers which will be between 40 and 40.100 times 0 and 1. So ultimately, you cannot tell the next real number after 40. That is the problem. And thus, this is uncountable set. This is uncountable. Uncountable. I am going to write two very much obvious but important statements. I never remember, but the things are coming automatically. I still do not know, but I know that I can write. And the first statement is before that, let me make you aware that we have understood the concept of a finite set, infinite set, countable set, and uncountable set. Okay. So I am writing the first statement as every finite set is dash dash dash. Can you please complete? Yes. I always used to give reference to the young people. Actually, I am not old simultaneously. Please, anyone?
Uncountable set.
Your name, please.
Yogansh.
Your name?
Yogansh.
Yogash. Yes. Every finite set is. Please repeat. Please repeat.
Every countable. Every finite set is uncountable.
Every finite set is.
Uncountable.
Every finite set is.
Uncountable.
Countable.
Uncountable कसे बाबा? Finite नेहमी countable असणार आहे. Every finite set will be countable. Suppose this is Sunday, Monday, like that. Okay. And the 7th is Saturday. Now set of natural numbers. 1, 2, 3, 4, 6. This is 7, 8, 9, and so on. So Sunday corresponds to 1, Monday 2, and so Saturday will correspond to 7. But what is our definition? A set is said to be countable if the elements in that set can be assigned one-to-one correspondence. Yes, Sunday 1, Monday 2, and so on, Saturday 7. Yes, every element in set A has corresponding elements in the set of natural numbers. So A is countable. In fact, every finite set is countable. Every finite set is countable. Okay. Can you make some another statement? Every something set is, definitely I am saying is means always is there, always. Here also always. And remaining part here. Please, can you complete? See, if we have a set, it will be finite or infinite or countable or uncountable. So we have made one statement. Every finite set is countable. Tell me another that will be always there. Please.
Every infinite set is uncountable.
Your name, please.
Aishwarya
Please.
Raut.
Aishwarya Raut. You told that every
Infinite set is uncountable.
every important set is uncountable. Now, here, see. Just now I had mentioned here one set. Suppose a set is 0, 1, 2, 3, 4. Okay, infinite. So tell me, this is finite or infinite? Finite है
Infinite.
infinite है सांगा बरं. Infinite है ना? This is infinite. Infinite. And then is it countable or uncountable? सांगा, countable है countable है?
Countable.
It is countable. Infinite and countable. It is countable infinite. So whatever you said is not correct. Huh? You said that every infinite set is uncountable. That is not the case. Okay, there might be some sets which are infinite and uncountable. Yes, I do not argue, but my statement. So you said that every infinite set is uncountable. That is not correct. Then what statement is always correct along with the first? Please. आपल्याला क्लर्क तयार करायचे नाही. क्लर्क तर BA BCom होऊन पण होतात. आपल्याला लॉजिकल पीपल तयार करायचे. प्रोग्रामिंग. सोपं आहे, काहीच कठीण नाही.
Sir.
सांगू? Yes, please. Your name, please, first.
Sir, एक बार uncountable set वापस बताओ ना.
Uncountable.
Yes,
Okay.
sir.
Okay. Now see, your weight. How much is your weight? How much
52,
is
sir.
your weight? Huh?
50.
50?
52.
50. 52. Exactly 52?
Don't know, sir. 52 or 53 might be.
Okay. See, if you are standing on a digital weighing machine, then it will show you 52.25 or something like that. It will not show 50, 51, and after 51 exactly 52. If we have a weighing machine which measures something like that, see, 40, after that 41, then 42, like that. If this is possible, then this is either the weighing machine is faulty, otherwise this is not, because see, there are if you have accurate until 2 decimal places, then hello. Okay, please. So what I was saying, that if your weight is it is not going to be exactly 52. There is very less probability that it will be exactly 52. It will be, so the thing is that I cannot write like that 40, 41, 42 until 100. So I have to write it as continuous. So this is 40 to 100. That means that 40 is the first element, that I know, but what is the next element after 40? Nobody can tell. I cannot tell, you also cannot tell, because it can be 40.0000 and then 1 somewhere. But between 40 and that number also there are infinite real numbers. So you cannot just tell, and we cannot write the elements in a set by separating commas. So we have to just write it as like this. this close interval 40 to 100, and that is as good as. So this is suppose real line. 40 is somewhere here and 100 is somewhere here. So this is continuous. Continuous means not discrete, going away from discrete nature, that is called as continuous. So you might have understood the name of your paper is Discrete Mathematics, and I will tell the definition of that discrete here. I hope you have understood the meaning of uncountable set. I believe that you have understood. Then tell me another sentence. Uncountable समजलं का सर्वांना? Has everybody understood uncountable? Yes or no? I will call any one of you. कोमल पांचा. कोमल पांचा. आणि मी नाव घेतल्यानंतर तुम्ही अनम्यूट करायचं, नाहीतर मी काय. नो. अदरवाइज व्हॉट विल हॅपन, मी डायरेक्ट याच्यामध्ये वेटिंग रूम मध्ये टाकून देणार. आपलं दोन्ही प्रथमेश दोन्हीला एकदा टाकलं होतं मागच्या लेक्चरला सोमवारी. कोमल. I think Yogesh Wag, please unmute yourself. Yogesh Wag.
Yes sir.
समजलं नाही का अनकाउंटेबल?
No sir. Example नाही समजलं.
एक्झाम्पल नाही समजलं. आता तुला कुठलं एक्झाम्पल सांग. फायनाईट इन्फायनाईट समजला का तुम्हाला?
Yes sir.
बरं काही प्रॉब्लेम घेतो मी आता त्याच्यामध्ये. just wait. I am sharing it once again. Sometimes it is creating some problem. Previous. Okay. So this was the previous slide. Yogesh, please give me an example of a set which is finite. Finite set चं उदाहरण द्या बरं एक.
Sir, even prime number. Even prime number.
Even prime number. Huh?
Yes sir. Only
even prime number finite कसं असणार आहे?
Sir 2 असणार फक्त.
अरे even prime number काय 4 नाही का even prime number? Sorry. Yes. Even prime number 2 is the only element, so it is a set which contains only one element, so it is finite. Oh, it is good. Then you can say this as set B as different English months of a year. So January, February, until the last will be December. So the first month is Jan, second is Feb, and 12th month is. So for every element in set B, there is one corresponding natural number. So B is a finite set. So this is finite set. Then I gave you an example of counting number of stars in the sky. So 0, 1, 2, 3, 4, 5 like that. So this is infinite set. This is infinite set. But it is countable still. See, I am explaining once again. So the first element of C corresponds to first natural number 1. Second element of C, that is 1, corresponds to second natural number 2, and so on. So there is one correspondence. And hence C, even though it is infinite, it is countable. It is countable. Did you understand this? Did you understand this or not?
Yes sir.
Okay.
Sir.
बोला.
Sir, you can't find cardinality of C set. So how is it countable?
Cardinality, you cannot find. So what is cardinality of C?
So number of elements.
Number of elements. How many elements are there? What is cardinality of C? Tell. What is cardinality of C? अरे सांग ना. What is cardinality of C?
n-1.
N. What is N? Huh?
Infinity, sir.
n-1 कसं येईल रे?
So
हा?
number of
त्याची तर infinity. It is infinity, na? It is infinity. So that's why the set is infinite. So being finite, infinite is different. Being countable and uncountable is different concept. See, C set is infinite set. But see, the elements in that can be written by separating commas. Okay. Now, I want to tell you
Sir,
another
that
example.
means
See,
every continuous element, every continuous set will be uncountable and every discrete set will be uncountable.
please repeat.
Sir, every continuous set will be uncountable and every discrete set will be uncountable. Every discrete set will be countable.
Yes. Yes,
Okay.
that is. So what I was saying here, every finite set is always countable, and can you tell me every what? Every uncountable set is always Sanga. Every uncountable set is always
Continuous.
infinite. Okay. So this is, and we'll be revising this quickly during the next session. And thanks a lot for perseverance you have shown. तुम्ही जी काही चिकाटी दाखवली त्याबद्दल तुमचे खूप खूप कौतुक करतो. धन्यवाद द्यायचा काही प्रश्न येत नाही. And yes, we have done it. Beyond. Yes, Swapnil Bagal. Yes. Thanks for reminding. And actually, I was searching for the same. So let me open that Word file so that I can share that link in the tab in the chat box. And I'm sharing tomorrow. Tomorrow we'll be discussing on logic, statement, and hope actually during your 11th and 12th you already studied a little bit, but when some topic is in higher class also, that simply means that you are going to learn at least few new things in addition to the prerequisites you have already studied. That is very much obvious. Yes, we will do that. And that is the last part of unit number 1. So I hope that everybody has picked. But it is really little unfortunate that the students are attending the lecture after half an hour, because they know that attendance is not going to be made available in the beginning session. So that is really very much unfortunate. So some clever students are also doing this. So that is really a pathetic for us. I think that you should be honest to yourself. So do not try to be honest with some other person, but try to honest with yourself. Then everything will be better and better. So thanks a lot. Have a good day ahead. Thank you.